All right, in this video, we're going to talk about properties of rational and integer exponents. You may be familiar with some of these properties already, and so we're going to be asking you to simplify the expression using these properties, okay? So the first one, when we are talking about exponents and we are using the product rule, the word product means multiply, okay? So when we are talking about two terms being multiplied, and that's represented by this dot here, we are actually going to be adding the exponents together as long as they have the same base. And by the same base, I mean the same big letter at the bottom. So if this was like a squared, let me make that a little thinner. Let's go. A squared times a to the fifth, let's say. Because I'm multiplying these together, I'm going to add the exponents up. So this would give me a to the seventh power. Okay, so that's the product rule. Then we have power of a power. And power of a power, these are just exponents. That's another way to think about exponents is with the word power. So if I have a quantity being raised to a certain power, that just means we're going to distribute this m into the parentheses and multiply them together. So if I had like a to the third to the fourth power, that would become a to the 12th because I'm going to multiply the 3 and the 4 together. Now, if you have an exponent on the outside, it's important that you distribute it to everything on the inside. So whether that's a number or any of your variables, it has to apply to everything inside the parentheses, which brings us to the next property, the power of a product. So if I have different quantities inside the parentheses, this means that these are being multiplied, so that's the product. And if I have a power on the outside, we need to make sure we distribute that to everything on the inside. So an example of this would be if I have like a times b inside to the fifth. Sometimes you may need to expand that and make it like a to the fifth times b to the fifth. Okay, so what that exponent does is it distributes all the way back in, and then you're able to continue on and do some simplifying there. So the next one we have is the division rule, and when we're dividing two terms with exponents, we're actually going to be subtracting their exponents, numerator minus the denominator. So the product rule, think of it as opposites. When you multiply, you add. When you divide, you subtract. Okay, so that's just another way to help you remember that. An example of this would be if I had like a to the ninth over a to the seventh. As long as they have the same base, the base stays the same, and then I'm going to subtract 9 minus 7. It's going to give me 2. Okay, and that would be my answer. Here's a note that a cannot equal 0, so that's the only restriction that we have on this one. Then we have power of a quotient. So this is similar to the power of a product. And what's happening is if I have a quantity being divided and then an exponent in the outside of the parentheses, this just means that I'm going to distribute everything to everything on the inside, whether it's multiple things being multiplied and then divided, whatever it is, okay? So for this one, let's just do a over b cubed would be the same thing as a cubed over b cubed. And this time I don't want the denominator term to be 0. Okay. Then I have the negative exponent rule. Anytime you see a negative exponent, you get rid of the negative by finding the reciprocal. And the reciprocal is you just flipping over the fraction. So I'm going to do two examples for this one. If I have a to the negative 2, I could rewrite that as 1 over a to the positive 2. So technically this is over 1. What I'm doing is I'm flipping the fraction over. This would also work the opposite way. So let's say I had 1 over a to the negative 3. And you might need to get rid of the negatives. Your final answer should never have a negative, but we're going to talk about why you necessarily don't have to flip it right away, what other things you could do. But in order for me to, let's say this is my final answer, to get rid of the negative 3 in the denominator, I would flip it over to the numerator. And I don't always need that 1 in the denominator. denominator, so I'm just going to write it as a cubed. So by you finding the reciprocal, it takes care of that negative exponent. So that's all you need to do there. Okay. Then we have the zero rule, and this rule just says that anything to the 0 power is going to be 1, no matter what, okay? So the reason why this works, and I think it's important for you to know why it works, is if I have, first let's think about what happens when I divide a squared over a squared. If I'm following the quotient rule up here, this means that I'm going to be subtracting 2 minus 2, okay? And that would give me a to the 0. If you think of it as just dividing, a squared divided by a squared, it just cancels out and gives me 1. That's why it works. That's why anything to the 0 power gives me 1, because essentially it's the same term in the numerator and the denominator, so it's going to cancel out to just give me 1. So anytime you see that 0 exponent, automatically turn that term into a 1. Okay, and the last thing that we are going to do here is the definition of a rational exponent. And so what is a rational exponent? I like to think of these as my inside the radical, my outside the radical. Okay, so this can be rewritten as that or as that. So if I were to give this to you as an example with numbers, if I told you to write that as a radical, you would, again, this is inside the radical, this is outside the radical. So outside is the 3, inside with the x is the 5. Or I could also technically write it as that's the outside, and then the 5, that was before it was distributed into the radical, okay? So however you want to think of it, all of these three mean the exact same thing as far as rewriting the rational exponent. So for these examples, we're going to state which property or properties we need to apply and then simplify each expression. We know that we're going to be done simplifying when there's no negative exponents, or where there isn't anything else that we can simplify that includes any numbers or anything like that, okay? So let's look at this first one. All we can do to this one is using the last property we talked about, actually, the rational exponents. And what we're going to do here is, again, I like to call this my in and my out. So this could technically just be rewritten as, let me make this a little thinner. My outside number is 5. My inside number is going to be the 2. Okay, that's it. And the property we used here is the rational exponent definition. So I'm done. There's nothing else I can really do there for this particular problem. Okay. Number 2 here. So all of these terms are being multiplied, and I do see a common base. All of these are x's. So my first step in this case, I'm going to actually be using the product rule. And my product rule tells me that if I have the same base, I'm going to just multiply all the bases together. So in this case, my 2, the 2 doesn't have any other number to multiply by, so I'm just going to get 2. And then I'm going to get the x. And my product rule tells me that I would add all of these together. So 2 plus the -5 plus the -4, and that's going to give me a -7. Okay? But I just mentioned that we don't want any negative exponents as my final answer. So then I'm going to go on and use the negative exponent rule. Just making sure. So negative exponent rule tells me that in order for me to get rid of the negative exponent, I have to find the reciprocal. Now, here's the tricky part, okay? The only thing that has a negative exponent attached to it is the x. The 2 does not have a negative exponent attached to it, so the 2 does not need to move. What needs to move is the term with the negative exponent next to it, okay? So this is how you know you're done. You don't have any negative exponents, and there's nothing else that you can simplify in this expression, okay? All right, going on to number 3. For number 3, we have a few things going on, and what's cool about these problems is that you can choose where to start if there's a lot going on. In this case, I'm going to start off by distributing this 3 through, and this is the power of a power. Power of a power or product, they're kind of, we're not really going to ask you guys to do this for every homework or on the test. Right now, we're just trying to get you used to using the terms, okay? So what this means is I'm going to distribute the exponent to everything. Now, because 3 has an imaginary 1 here, or invisible 1, that's just 3 times 1. But when I get to the m, this is going to become 3 times 2, which is 6. And then the outside, these are all being multiplied. This still has a negative 4, okay? So I'm going to simplify this. It's important that you recognize this is not just 3 times 3, it's 3 times 3 times 3. So I'm going to multiply that out, and that gives me 27. When I look at this piece right here, these have the same base. They are both m's. So I'm going to just use the product rule for this one and multiply those together. When I multiply exponents, that means I'm just going to add them, and that gives me m squared. Okay, so I don't have anything else. That would be my final answer in this case. All right. So again, for these, you can choose what you want to do, what you want to try, as long as you're using the right rule, then you should be okay. So let's try this one. For this one, I'm going to start with power of a product. Again, because I'm going to distribute the 6 to everything. Now, there's 2 ways that you can actually do this, and let me back up. I changed my mind. I'm going to actually simplify what's inside the parentheses because that's going to make it easier before I distribute everything, okay? So inside the parentheses, I have 2 different bases. I have y's and I have z's. So I'm going to simplify the y's first by using the product rule. And that means I'm going to just combine them into one single term. So for the y's, I'm going to add 2 plus negative 5. And that's going to give me a negative 3. And for the z's, I'm going to add 3 plus negative 2, which is just 1. And then I still have the 6 on the outside. Okay, so it is always a good idea to simplify what's inside the parentheses first before you distribute the 6. In this case, if they were all different letters, then I would go ahead and just distribute the 6 from the outside. So now I'm going to apply the power of a product. Okay, now if I want to go ahead and distribute the 6 first, there's nothing wrong with that, and I can show that here in a second. But what's cool about all these rules is you can use them in any order as long as you're using the rule correctly. We're going to get to the same answer. So when I use power of a product, I'm going to distribute those through, and that's going to give me, I'm going to drop the parentheses after I distribute, y to the negative 18, z to the positive 6. Okay, and then I am one step closer. I see a negative exponent, so I don't like that. So for my negative exponent, I know I have to flip just the part that's negative. So only the y has a negative exponent, so only the y needs to move to the denominator. The z is positive, so I leave it in the numerator, okay? Now really quick, I'm going to show you what happens if I were to distribute that 6 from the beginning. So let's say that I wanted to distribute the 6 through, totally fine. That would just give me to y to the 12th, y to the negative 30, z to the 18, z to the negative 12, and then you would apply the product rule anyway and combine these into one term, which would give me y to the negative 18, z to the positive 6. So I end up in the same place. It just depends on what makes sense to you, which of the rules make more sense for you to follow in that order. Okay? Okay, moving on to the next one. Again, you can approach these problems however makes sense to you. For me right now, I'm focusing on this 0 property. And I know that anytime I see a term to the 0 exponent, I'm going to replace that with a 1. So that's 4 times 1, y to the negative 2, z to the third over 4x. So 4 times 1, I'm just going to replace that with the 4. So let me replace that with the 4 here. And then other than that, I'm going to see what else I can simplify. So in this case, I have a negative exponent, so I'm going to use the negative exponent rule, which means I just need to bring that to the bottom, okay? So in the numerator, I still have a 4, and I still have a z to the third. And in the denominator, I have a 4x and then y squared. The last step is going to be to simplify. I have 4 divided by 4, so don't get confused with that. That still just means 4 divided by 4. So just simplify that a little bit further. 4 divided by 4 is just going to be 1. So my final answer is z to the third over x y squared. Okay, so that's what we mean by simplify. If you can, don't forget about your actual like number rules. You're still dividing 4 divided by 4, and that should be enough. Okay, moving on to 6, we just have a few more. Again, however you want to approach this, whatever makes sense to you. I'm going to start off by distributing this negative 2 to everything inside the parentheses, okay? And that's called power of a product. Oops, forgot the R. So I didn't do anything with the first few terms here, but I am going to distribute that negative 2, which is going to give me this, and then start approaching it from there. So I like to use the product rule to simplify like all my x terms together, all my y terms together, and so on. So I'm going to go ahead and use the product rule and to combine these into 1. Now, x and this is technically a 1, so 1 plus negative 2 is going to give me x to the negative 1. And then my y's, 5 and negative 6 is going to give me negative 1, and then I have 3 to the negative 2, okay? Now, I know that all of these have negative exponents, so I'm going to use the negative exponent rule. And in this case, all of them have a negative exponent, so they're all going to the bottom, which means if they're all going to the bottom, what's going to stay on top? Okay, it's just going to be a 1. It's just a reciprocal, because if I'm looking at it just in the previous step, this is technically all over 1. There's always, all whole numbers are always over 1. Technically, we just don't write that. So then I'm bringing down the x to the 1. Doesn't have to be there if you don't want to put the 1 there. And then 3 squared comes down. Now you can simplify that a little bit further. What is 3 squared? 3 squared is 9. And generally we like to put the number in the front. So that is how you would write your final answer here. Okay? So given that, go ahead and pause this video and try 7 and 8. See how far you can get. Use the properties. This is all about getting comfortable. Don't forget to write your properties so that you're getting used to it. Again, this is not going to be an expectation every single time, but right now we are just getting you to practice that, okay? And then come back and we're going to go over the answer. Alright, so again, start wherever it makes sense for you to start. I'm going to simplify the denominator here first by using my product rule. So I'm going to multiply those two together, and then I also see that I have some numbers that I can multiply together. So I'm using the product rule. So I haven't done anything to my numerator yet. 3 times 6 is 18. And then I have x to the negative 1, and 4 is positive 3. Then I have a y in the denominator, okay? Now, if you didn't start with this step, that's totally fine. Just wait and see what you got. So I would then use my division rule, which means I'm going to take the common basis and subtract the exponents. So division rule. 3 minus 3 is going to be 0. Okay, so it's going to cancel out. Remember, there's going to be an invisible 1 there. But then I also have the 3 minus the 1 here, which is going to give me y squared. Now, I do have this 9 and 18. Those are not exponents, so you would just treat them like normal. How would you reduce the fraction 9 over 18? Okay, hopefully you realize that reduces to 1/2. So technically, I could write a 1 and then a 2 in the denominator. Now, that 1 isn't really necessary, so you could just leave your final answer as y squared over 2. And that would be it. You are done. Okay, so however you ended up doing that, if it took you more steps, that's totally fine. Again, just use whatever rules you want to use as long as they are used correctly. And the last problem here, I'm going to, again, start by simplifying my denominator. So I have a lot going on here. X to the 4th, x to the negative 5th can combine. And I'm also going to be combining my z's. So I am using the product rule first in the denominator. All right, when I put my x's together, 4 and negative 5 gives me a negative 1. My y is still the same, it didn't combine with anything. And then my z, 4 and 7 is 11. Oops. Undo. Okay. Now, I am going to combine steps here because there's not much going on in the numerator. So in addition to this, I'm also going to use the power of a product in this step. Okay, so that means I'm going to distribute this squared to everything, giving me 4 squared, x to the 4th, z to the 6th. Okay? And then I'm going to use the division rule. So the division rule means I'm going to look at my x's in the numerator and denominator and simplify by subtracting. Same thing with my z's here. So division rule. And you can also simplify things when you're doing these steps. So like 4 squared, I know is 16, okay? So that's going to go in the numerator. Something that's not going to move yet, at least, is the y to the 3rd. All right, so stuff like that you can just keep there. So when I do exponents, 4, so x to the 4th and divided by x to the negative 1, I'm technically doing 4 minus negative 1. Which gives me a positive 5. Okay, so this is going to be x to the 5th. And because it's a positive exponent, it's going to go in the numerator. So positive exponent goes in the numerator. And when I do the z's, here's what's going to happen. Z to the 6 over z to the 11. We have 6 minus 11, which technically gives me a negative 5. So 2 options, okay? You can either say, okay, that means z to the negative 5. When it's negative, though, we know we have to find the reciprocal. So another way you could approach this is say, oh, I know it's going to be negative in the numerator, so it can come straight to the denominator. Because when you switch the direction, it's going to get rid of the negative there. So if I were to make this all pretty, you would just leave it as 16x to the 5th, and then y cubed z to the 5th, and that would be your final answer. Okay, so just be careful with the dividing. I think that's going to be the more difficult part. Always subtract numerator minus denominator, and then always put it in the numerator. Whenever you finish it, put the actual answer in the numerator, and then if there's a negative exponent, then you can go ahead and just put it in the denominator by using that negative exponent rule. Okay? And that is the end of these notes.